So we have come to the end of the chapter. This is the very last topic. This is very important. You can expect 7 marks for your sims. And if you see, Laplace of f of t is f bar of s. This we heard many times as of now. But see this, Laplace of y of t. From now onwards, for this last topic, we will not see f, we will see only y. Okay? Habituate to it, y. Just like f, habituate to y. Okay? So now coming to this third point. Laplace of y dash of t is s into y bar of s minus y of 0. I have already told you starting that this property we will be using in the last topic that we have come here. Laplace transform derivatives. If n is 1, that means one time derivative. So I will get s into f bar of s minus y of 0. Okay, so this we are using here. So how to remember? Nothing. You just see, if it is 2, you'll start with s square. If it is 3, you'll start with s cube. Okay, you'll start and slowly s term you will decrease, and y bar of s, y of 0, y dash of 0, y double dash of 0, this continues. Okay, s powers reduce and these continue in this order. First y bar of s, then y of 0, then y dash of 0. Okay, bar, nothing, dash. Okay, so this is how we need to remember. So just try for Laplace of y 4 dash t. Okay, let's try. S power 4 y bar of s minus s cube y of 0 minus s square y dash of 0 minus s y double dash of 0. Next s is over, next nothing, so minus y triple dash of 0, like that. Okay, s cube, s square, s, we will not have s anything. Okay, this is the sequence you need to remember. This is very important. Make sure you make note of this. So this is the last thing. So overall we have only two sheets: definition, some formula, then some formulas we have used inside out in our chapter. Okay, these two, convolution theorem and these two of our 7 marks. Okay, these are some trigonometric formulas, and then properties. So only did this just one page for last chapter. Okay, so now without wasting any further time, let's go to the last topic, questions. This is how questions are framed. Solved by using Laplace transform. So you will be given a differential equation and you have to solve it using Laplace transforms. So first let's write it in this form. It is y double dash of t minus 2 into y dash of t plus y of t is equal to e power t. Okay, so now first step is taking Laplace on both sides. Why Laplace? Because I told whenever t is there we take Laplace, whenever s is there we take inverse Laplace. Okay, taking Laplace on both sides. So write this whole term, Laplace of e power t. So now what is Laplace of y double dash of t? Okay, let me write it. So now we will be using those formulas we just saw. Okay, just try without seeing. First one is s square into y bar of s minus s into y of 0 minus y dash of 0 over next minus y dash of t formula. So Laplace of y dash of t formula, s into y bar of s minus y of 0 plus Laplace of y of t. You know it's what? Y bar of s. That is simple. You know, no, Laplace of f of t. What is Laplace of f of t? F bar of s. Just like that, Laplace of y of t is y bar of s. Okay. This side 1 by s minus 1. Clear? Now, what we should do is take y bar of s is common. So, you will get s square and here minus 2s plus 1. And next you will be taking y of 0. So what are the terms we have? Y bar of s, y of 0, y dash. So that we have to take common. Okay, we'll take y of 0. So here minus s is there, and any more? Yeah, here we have minus into minus plus 2. Okay, next is y dash of 0. How many are there? Y dash of 0? Only 1. So directly let's write like this. So now see, in question it's already given two values for you. So now we'll substitute those two values here. Okay, so y bar of s into s square minus 2s plus 1 is plus, what is y of 0? 2. So let me write directly. 2 into 2 is 4 minus 2s, minus into minus is plus 1. Okay, y dash of I substitute it is equal to 1 by s minus 1. So I will be leaving only y bar of s this side. So what will be this? I have s minus 1, multiply this as 2s square. I'll get 1 plus 2s square minus 5s minus 2s plus 5. Okay, so I'll take this down, s square minus 2s plus 1, which is 1 plus 5, 6. So I'll get 2s square minus 7s plus 6 by, what is this roots? If you find, you'll get s minus 1 in whole square. So total it will be cube. You get s minus 1 whole square. So now we have come. What is y bar of s? Laplace of y of t. So now if you see, we have come to partial fractions. So what is my y of t? Laplace inverse. How do I find this Laplace inverse? By partial fractions. So finally I have to find y of t, right? That is the solution. Okay, so consider 2s square minus 7s plus 6 by. So when a linear is having power, so how did I say? A by s minus 1 plus b by s minus 1 whole square plus c by s minus 1 whole cube. Okay, because it is linear, we're going to take all constants, don't take quadratics. This is how we take when linear is having power like this. If it's 4, I'll take d by s minus 1 whole power 4, like that. Okay, so now what we should do? We should compare coefficients or put some values and find the values of a and b, c. So in denominator I'll get s minus 1 whole cube, which eventually get cancelled. But see, numerate a into s minus 1 is there, so s minus 1 whole square. B into only 2 is there, so I need one more. C into no need of anything. So now I'll put s is equal to 1, then I'll get this one. I'll see, you solve that. Putting s is equal to 1, I get c is equal to 1. Comparing coefficient for a, I can of s square. Compare coefficient of s square, I get a is 2. Then next I can add minus 2a plus b is minus 7. So I get b is minus 3. Coefficient of s. So now these three values I'll substitute here, and I'll easily find Laplace inverse by linearity property. Okay, so now by linearity property I can write it like this. Now I will use my first shift property. So this I can write it directly. E power minus 1 is there, so plus t. Okay, for this how will we write? I'll shift my s minus 1 to s. 1 by s square. Before that I have to write e power t plus 1t. Okay, here I'll shift my s minus 1 to s happily, but before that I have to write e power t. Okay, So this will be 2 e power t minus 3 e power t. What is Laplace of 1 by s square? It is t. It's cube. T square by 2 factorial. So this is your final answer. So this is the next question. Solve the following differential equation by using Laplace transform. They'll give like that. And see here, where y is dy by dt is 0 when t is 0. So before, if you see, we have got something like this, y of 0 and y dash of 0. They have given some values. But now we are given like this. That means y means y of t. Okay. dy by dt means y dash of t is 0. That means when t is 0, so let me put 0 here in place of t. So indirectly they gave me that y of 0 and y dash of 0 values are 0. So you should understand that when you see this statement. Okay. Okay, clear? This is indirectly they'll give. Okay, now let's do this. So what is this? Y double dash of t plus 2 into y dash of t and minus 3 into y of t is sin t. So what is, should we apply? Laplace or inverse Laplace? Laplace. Apply Laplace on both sides. So sorry, Laplace. So now with that first formulas we wrote, that we have to apply. So what is Laplace of y double dash of t? S square y bar of s minus s into y of 0 minus y dash of 0. Okay. Plus 2 into s into y bar of s minus y of 0. Okay. Minus 3 into y bar of s. Okay. So now we should take y bar of s common. See, s square 2s minus 3. Next we should take y of 0 common. If you take or don't care because it is 0, but we have to show in exam. So this will be minus s and here minus 2. Okay, and next y dash of 0 minus 1 minus 2. So now this will be 0, this will be 0, so all these terms will be cancelled. Only will be left out with this. So y bar of s is 1 by s square plus 1 into s square plus 2s minus 3. Okay, write these as zeros in exam. So here, how should we write partial fractions? Because y bar of s is nothing but Laplace of y of t. So y of t is Laplace inverse of this. So this is quadratic. So we have two quadratics. So when, but if you see here, s square plus 2s minus 3, we have roots, which is, let me write like this, s minus 1 into s plus 3. So now I will divide. Consider 1 by s square plus 1 into s minus 1 into s plus 3 as as plus b by quadratic. Because this quadratic I took linear. Because these are linears, I am taking constant a, b, c, d. Okay. So now how should we solve? So first let's write it like this. As plus b, so s square plus 1 into, so what I should write? As plus b into s minus 1 into s plus 3 plus c into s square plus 1 into s plus 3 plus d into s square plus 1 s minus 1. So now I'll put these two cancel, will be left with numerators. Put s is 1 So this will be 0, this will be 0, I'll be left out with this. So I'll get 1 plus 1 2, here 1 plus 3 4, so 8c is equal to 1. So my c is 1 by 8. Okay, now I'll put s is equal to minus 3. This gone, this gone, only this is left. Minus 3 whole square is 9, 9 plus 1 is 10. Minus 3 minus 1 minus 4. So minus 40d. So d is minus 1 by 40. See how easy we're getting if you put s is there. So next I'll put s is 0. Then my a will be gone. Minus 1 plus 3. So minus 3b. This side also 1 will be there. Here minus 3b. Here 1 into 3. 3c. Here minus d. So 3b is equal to 3c, means 3 by 8 plus 1 by 40 minus 1. If you solve this, b you'll get minus 1 by 5. At a will compare coefficient of s cube. So here I got a, here I got c, here I got d. So here this side no s cube coefficient, so 0. So here if you put a, you'll get minus 1 by 10. Substitute c and d, you'll get. So now, so this in place of this, I have to substitute all the values and find Laplace inverse. So now using linearity property, I can write it as Laplace inverse of minus 1 by 10s minus 1 by 5. It is Laplace inverse of 1 by 8, Laplace inverse of 1 by s minus 1 minus 1 by 40, Laplace inverse of 1 by s plus 3. So now see this. Again this will be divided. So again I can apply linear property. Minus 1 by 10 Laplace inverse of s by s square plus 1. This term. Okay. Next this. Minus 1 by 5 Laplace inverse of 1 by s square plus 1. I applied for this term. Okay. So here what I'll get? 1 by 8 e power t. Next. Here minus 1 by 40 into e power minus 3t. Direct. Okay. So now this one. This is cos formula. So I'll write here cos t. Here sin t. Here 1 by 8 e power t minus 1 by 40 e power minus over. So what is this? This is my y of t. Okay, Laplace. We wrote now y of t. So we are done with solution. Ordinary differential equation using Laplace transforms. This is important, very very important. See, they're confusing you. Until now they gave d square y by dt square. So you used to write once. Let's show you. So before they used to give like this, d square y by dt square. So how you used to write this? Y double dash of t. Okay. So now they're giving like this. So you will write this as x double dash of t. Next is 3x dash of t plus 2x of t is e power minus 30. Okay. Minus t. So next you should apply Laplace on both sides. Then what is the answer? Before we have in y. Okay, so we got s square y bar of s. Now you'll write s square x bar of s. Okay. Okay. 3 into s x bar of s minus x of 0. plus 2 into x bar of s. Laplace of x of t is x bar of s. Okay, this side I'll get 1 by s plus 1. So now what should I take? X bar of s common. So s square plus 3s plus 2. 3s and here 2. Next x of 0 common. Next x dash of 0. Because my x of 0 is 0, I'll get whole term 0. So what will be there here? Minus s and minus 3 is equal to, so s square plus 3s plus 2. This will be 0. This will be 1. So this is minus x dash. Minus 1 is 1 by s plus 1. So shift it that side. So I'll get x bar of s 1 by s plus 1 plus 1, which is s plus 1 plus s plus 1. So s plus 2 by s plus 1. Okay, and into this will be there, so this will go this side. So directly I'm writing, don't write like that. Okay, so now what is x bar of s? Laplace of x of t. So x of t is Laplace inverse if L goes to that side. So finally I'll get s plus 2 by s plus 1 into these roots are s plus 1, s plus 2. Use calci for roots. So cancel. So I'll be left with Laplace inverse of 1 by s plus 1 whole square, which is very easy. By using first shift property, I'll shift my s plus 1 to s. So this will become e power minus t, Laplace inverse of 1 by s square, which is t over. Okay, Laplace inverse of 1 by s square, which is t. This is first shift property. Answer is done. So this is 7 marks question. Just you need to not get confused with y of t. Yx is there. Don't get confused. Okay, that's it. See, no need to apply partial fractions if you properly see that s plus 2 is getting cancelled, and if you properly see that s plus 1 whole square, this is first shift property. If you see that, no need to apply partial fractions and waste time. Okay, the last important question in this topic is very lengthy question, because the moment you see that RHS is big, you can easily say that. So let's see. First we'll apply Laplace on both sides, and see, this is the question. They will give it like this: solve using Laplace transforms. Okay, so when I apply Laplace on both sides, so what is Laplace of y double dash of t? S square y bar of s minus s into y of 0 minus y dash of 0. Okay, minus 3 into y dash of t is s into y bar of s minus y of 0 plus 2 into Laplace of y of t is y bar of s. This side Laplace of 40, so it will be 4 into 1 by s square. Laplace of e power 3t, 1 by s minus 3. Okay, now we should take y bar of s common. I'll get s square minus 3s plus 2. Next I'll take y of 0. So I'll have minus s and plus 3. Next I'll take y of 0. How many are there? Y dash of 0. Only one. Directly I'm writing minus this one. So here I have 4 by s square plus 1 by s minus 3. So y bar of s into What is my y of 0? 1. So this y is was minus 1. So we'll shift it that side. 4 by s square plus 1 by s minus 3. What is this? 3 minus s. Here it will become s minus 3. Here minus into minus plus 1. This side it will become minus 1. So finally I'll get this side. 4 by s square plus 1 by s minus 3 plus s minus 4 by this also. S square minus 3s plus 2. So this is my y bar of s. What is y bar of s? Laplace of y of t. So what is y of t? Laplace inverse of this whole thing. So now we have to find Laplace inverse of this whole thing. Okay. So let's solve it. 4 into s minus 3 plus 1 into s square plus s minus 4 into s square into, so I am taking all common LCM. This s square s minus 3 I am sending directly to denominator. So this is how our partial fraction now looks like. Now we have to find this solution using partial fractions. So how do we consider? A by s, b by s square, c by s minus 3. Then we have these roots s minus 1 and s minus 2. So I'll directly write here. So total how many A, B, C, D, E. Up to E I have to write. Okay. Now LCM. What is the LCM? S square, s minus 2, s minus 1, s minus 3. This side also same. So this get cancelled. Now we should care about numerator. How are we going to write? So this side we'll have, if you solve completely, s power 4 minus 7s cube plus 13 s square plus 4s minus 12. Okay, solve that. Numerate. Now see here. A into, I have s. So I need to write s into s minus 1 into s minus 2 into s minus 3. For B, s square is there. So I should write all this. C, this, s square into s minus 2 into s minus 1. I'm writing here. D key, this, s square into s minus 2 into s minus 3. E key, this, s square into s minus 1 into. So finally we wrote. So now we have to put, for easy calculations, we will put s is equal to 1. Okay, this is gone, this is gone, this is gone, this is gone. So we'll get d value if you put s is equal to 1. So put here 1. So you will get d value is equal to minus 1 by 2. Next put s is equal to 2. Everything is gone except e. So here e value, you will get it as minus 2. Next put s is 3. Gone, gone, gone. So you'll get c value, which is 1 by 2. Next, to get a value, you should put 1 petna, 2 petna, 3 petna, 0 petna kuda podu. So a will find last and put s is equal to 0. So you'll get b value, which is 2. Okay, put s, both put LHS and RHS, you'll get these values. Okay, finally everything is over, but we are not getting a value, so we'll substitute all these values to get a value. So coefficient of s power 4 is 1 and here it is a. So let's see. a plus, and c also s square will get coefficient c plus, d also c square of power 4, e, yeah, so in b only you will not get power 4. So comparing coefficient of s power 4, now you'll put all the values and you'll get a value as 3. So finally we'll write Laplace inverse of y of t, 3 by s plus 2 by s square, 1 by 2 by s minus 3, minus 1 by 2 by s minus 1, minus 2 by s minus 2. Now final answers. Laplace inverse of 1 by s is 1, s square is t, this is e power 3t, this will be e power t, this will be e power minus 2, so plus 2. So these are your final answers. To get this quickly, you need to practice those formulas. Okay, so we're done. So this is some lengthy question because we have got big partial fraction, that's it. Overall, everything is easy. But I just want to show you something. So when we get this, we have given y of 0 and y dash of 0 as 0. So we'll take Laplace, then we'll write the formula, then we'll take y bar of s is common. Okay, we'll send all that side. Then we'll take y of t, Laplace inverse. So now while considering, see, I have both quadratics here. Before I used to write linear. So I just want to say that don't forget, here a and b are used to make another linear with c and d. Okay, that's it. So you will make partial fractions like this: as plus b, cs plus d, and you will find comparing coefficient of s cube, s square, and s. Okay, you will get abc values. Then you will substitute, and you will, very important thing, minus 2 Laplace inverse of s by square. This is easy, you'll do. Okay, but see this term, we don't, to use first shift property I need something. So before I said no, check for s plus 1 whole square, which is s square plus 2s plus 1. So I can write it as s plus 1 whole square plus 1. So I want to create s plus 1 in numerator also. So how will I create s plus 1? Here 2s is there, so multiply 2s plus 2 I'm getting, but I need to get 3, so I'm adding 1. So now see, this is my minus 2 cos t, this is sin t, and this one I'll shift my s plus 1 to s. So for that, so I'll write e power minus t, Laplace inverse of 2s plus 1 by s square plus 1. So now it's easy. So you again divide it. So minus 2 cos t plus sin t. So see this. Laplace inverse of 2s by s square plus 1. Laplace inverse of 1 by s square plus 1. So this will be 2 outside, 2 cos t. This will be sin t. Okay. E power minus t. So this is your final answer. Don't cancel this and this, okay? E power minus t is there, don't cancel. So this is plus. So this is your final answer.